A simple introduction to ordinary hypergeometric function. First of all, let us begin with the geometric function. So basically, 1 plus x square plus x cube. Yeah, this one goes on. Let's say this one is a geometric function. Yeah. Now, what happens in hypergeometric function is, let's say we have 1 plus a b c d e f x, yeah, plus, and then a plus 1, b plus 1, c plus 1, d plus 1, by e plus 1, f plus 1, yeah, and then x square by 2, factorial. Okay, and similarly next term, let it be a plus 1, a plus 2, yeah, and also similar for b, similar for b, also b plus 1, b plus 2, c plus 1, c plus 2, d plus 1, d plus 2, and over here e plus 1, e plus 2, f plus 1, f plus 2, yeah, and then over here x cubed by 3 factorial, and it goes on in a similar fashion. So this function over here is known as a hypergeometric function. Yeah, and the notation is over here in f, we first of all write the number of variables that are over here in numerator. There are 4 variables, and then in denominator there are 2 variables. Yeah, and before the semicolon there are variables of numerator, variables of denominator, and then our main variable. So we have a comma b comma c comma d, semicolon e comma f, semicolon x. So this is the hypergeometric function notation. Yeah, and the good thing about this function is it is able to capture many different known and unknown functions and can help us study their properties. Yeah, so basically the functions like, let's say, logarithm function, sine inverse function, sine x, cos x, all of those functions can be written in terms of hypergeometric functions, and also many unknown functions can also be written in terms of this function. And we have studied this function a lot, that we can also predict the properties once a function is in this notation. Now we have some notations like a of a, and then this 2 is just a plus 1. Yeah, so this can be written as a of 2, and this is b2. Now this is a of 3. Yeah, similarly let's say b of 3 will be b plus 1, b plus 2. This is known as Potsdamer notation. Yeah, and let's say if this is a of n, yeah, then we know that this is 1 less than the n, so it goes up to a plus n minus 1. Okay, now this is just a hypergeometric function generalized, and now this is an ordinary hypergeometric function, also known as Gaussian hypergeometric function, and this has been studied a lot, and it's also the most frequently used hypergeometric function, also known as ordinary hypergeometric function. So basically over here we have 2 variables in numerator, 1 variable in denominator, a and b, semicolon c, semicolon g, and this can be written as going from n equals to 0 to infinity. Yeah, basically first of all let me write it in expanded form. So first of all there will be 1, and then a b by c x to the power 1 by 1 factorial, plus a plus 1. Now I can write that in a notation. Yeah, so basically a plus 1 can be written as a base 2. Now this can be written as a base 1, b sub 1, c sub 1, and a sub zeros, yeah, these are just ones, b sub zeros by c sub zeros, yeah, and then x to the power 0 by 0 factorial can be written over here as well. A sub 2, b sub 2, by c sub 2 x square by 2 factorial, and then a sub 3 b sub 3 c sub 3 and then x cube by 3 factorial. So this is what ordinary hypergeometric function looks like. Yeah, and this will be sum going from n equals to 0 to infinity. So we have basically a sub n, b sub n by c sub n and x to the power n. Yeah, so this was the basic introduction of the hypergeometric function. And like there are like many integral results for some complex integrals that come in terms of hypergeometric function, and there are no other like elementary or known functions. Yeah, and in that case it can be useful. And also this has a very nice integral representation which we will discuss in the upcoming videos. Yeah, so this was a brief introduction, and check out my next video to learn about how some of the functions can be represented through hypergeometric functions. So this was it. Thanks for watching. Look forward to seeing you in the upcoming videos too.